Hi everyone. Today we are going to discuss retaining wall. Myself Dr. K. Yuvraj, Department of Civil Engineering, K.S.Rangasamy College of Technology. These are the list of content we will discuss in the class one by one. Earth pressure theory in soil mechanics, plastic equilibrium in soils, then active and passive states of soil, then Rankins theory with active pressure and Rankins theory with passive earth pressure, then Rankine theory with cohesive soil, then what is cohesionless and cohesive soil behavior, and then finally concluded application in foundation and or retaining wall designs. Okay, first introduction. Here earth pressure refer to the lateral pressure exerted by the soil on a retaining structure like a wall, sheet pile and basements. The intensity of this pressure depends on many factors such as soil type, depth of soil, presence of water, okay, and then movement of retaining structure. Understanding this pressure is essential for designing safe and stable retaining wall, right? Next one is a plastic equilibrium in soils. Here soil reach plastic equilibrium when the maximum shear strength of the soil is fully mobilized. At this stage the soil is at its limiting condition and cannot resist any additional forces without failing. Okay, then there are two possibilities. In the active state the soil tend to move away from the wall, and in the passive state the wall pushes into the soil, mobilizing maximum resistance. Okay, and then active and passive state. Here in the active earth pressure condition the retaining wall moves slightly away from the soil, causing the soil masses to expand, and then the pressure on the wall decreases until it reaches a minimum value, which is the active pressure. Okay, and the passive earth pressure means the wall move into the soil, compressing it and increasing the pressure until the soil offer maximum resistance. Is called passive state theory. Okay, and then assumptions of Rankins theory is based on a few simplifying assumptions to make a calculation easier. It assumes that the soil is homogeneous or extend infinitely in depth, while the retaining wall is smooth or vertical and the backfill surface is horizontal. Okay, then originally the theory was developed for dry and cohesionless soil, but it cannot also be extended to cohesive soil with modification. Okay, and then this one is a Rankine theory with active earth pressure. This one is a formula for the cohesiveless soil for the active earth pressure, Pa equal to 1 by 2 gamma h square Ka. Here gamma refer to unit weight and h is equal to height and pi is equal to angle of internal friction. Here Ka is calculated by using the formula of 1 minus sin pi divided by 1 plus sin pi. Here pi is the angle of internal friction of soil. Okay, then Rankine proposed his theory in 1857 and it is still widely used today to calculate the earth pressures. According to theory, the distribution of earth pressure on the retaining wall depends on the soil properties and the wall movements. Next one is a Rankins theory with a passive earth pressure. Here formula for passive earth pressure Pp equal to 1 by 2 gamma h square Kp. Here Kp equal to 1 plus sin pi divided by 1 minus sin pi, but in the active earth pressure 1 minus sin pi divided by 1 plus sin pi. These are the differentiate. Okay, here passive earth pressure developed when the wall move towards the soil and pushing and compressing it. At this stage, the soil offered maximum resistance against the movement and reached the plastic equilibrium condition. Okay, it's called a passive earth pressure. Is denoted PP. Okay. And rankings theory with cohesive soil, the formula is tau is equal to C plus gamma sigma tan pi. Okay, here C is a cohesive, that means shear strength of the soil we need to calculate, and then pi is the angle of internal friction. Right. Here ranking theory can also be applied to cohesive soil like a clay by including the effect of cohesion. In such cases, the shear strength is given by the formula. Okay. The presence of cohesion provided extra resistance, thereby reducing the overall earth pressure acting on the retaining wall. Next one is a cohesionless and cohesive soil behavior. Here in cohesionless soil like a sand or gravel or earth pressure depends mainly on the angle of internal friction, all you know that, and no tension crack are formed here. But in the cohesive soil like a clay, presence of cohesion reduce the earth pressure significantly compared to the sandy soil. It is very important, note it. And however, the clay soil can be sometimes develop a negative earth pressure near to the top, so which leading to the formation of tension crack. Okay. Then advantages or merits of retaining wall. Here retaining wall provide support to unstable slopes and prevent soil from collapsing, which ensure safety in construction. Okay. They are useful in controlling flood and water flow in low lying area or river banks. In addition, retaining wall allow effective land utilizing by creating level spaces of roads, buildings, gardens, while also additional functions and aesthetic value of the landscape. Okay. In the disadvantages of retaining wall, you noted that despite their unusefulness, retaining walls also have some drawbacks. They involve higher construction cost because of the material, excavation and reinforcement required, if required. Okay. Furthermore, they have design limitation, require regular maintenance, and may possess environmental challenges like blocking natural water flow with the risk of failure if not properly designed. So many drawbacks was occurred during the construction time. Okay. And then finally this brings us to the end of the presentation on the retaining wall and earth pressure theory. We have looked at the concept of active and passive earth pressure and ranking assumptions, we know that, and the differentiate between cohesive and cohesiveless soil, we know and we learned that. And finally, I hope this session help you clearly understand why retaining wall are designed the way they are in real world application. Okay. Thank you all. Thank you for watching.